So they are not picking their calls.
Okay.
Is this what you wanted to see?
Yeah, I was looking at why are these people calling me? Hello?
Hi.
Okay, it's here. Okay. Hi, good morning. Can you hear me, please? Hello? Hello?
Yeah, good.
Hello? Can you hear me,
Yes,
please?
sir.
Good morning. Who is calling on the WhatsApp page again?
Good morning.
Good morning. All right, so let's start the class, okay?
All right.
All right, so this weekend we'll be looking at Unit 4 and we'll be focusing our attention on issues on how dynamic the Earth is or the changes about the Earth. Where we will focus or be specifically looking at continental drift, sea floor spreading, plate tectonics, volcanism, earthquakes, and then mountain buildings. These are the things that we will be looking out for today. So kindly indulge. I plead your indulgence to take part in it. Now, first, let's look at continental drift. Um, it's, now, when we look at continental drift, one will ask, what is continental drift? Now, many years ago, the Earth was considered as one. Um, Please just a moment. Let me see if I can get you this short video on it. Okay. All right. So I'm not getting the video. So in the past the Earth was considered as one with just a continent. Now the continent was known as Pangaea. The continent was known as Pangaea. Now, according to Alfred Wegener, his hypothesis mentions that the continent began to break off. Now, in breaking off, it first divided into two, one to the north and another to the south. Now, is there a question? Or someone just joined? Um, Please, the person using the name Rebecca, can you please put your hand down so that just in case someone has a question, we'll be able to see the person. Thank you. All right. Now, with Alfred Wegener, he believed that the Earth was together, the continent was one. That is, it formed a supercontinent called Pangaea. Now, with that Pangaea, he believed that over time it began to break off. And in breaking off, it broke into two, one to the north and another to the south. So first a supercontinent called Pangaea, then it began to break off. So in breaking off, it broke off into two parts, one being Laurasia to the north and Gondwanaland to the south. Now over time, as a result of what we call tectonic movement or plate movement, the Earth further divided into the current continents that we have. Now let's see. Is Hamdia here? Hamdia, how many continents do we have? Hello, Hamdia. Hello. 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 Yeah, can you hear me now?
Hello, sir. You can hear you.
Hello. Oh,
Hello, sir. You can hear you, sir.
so I was saying that we have the continental Pangaea. We have then it broke into two. Then it became Gondwanaland. Then currently we have what? We have the continents as we have it. Then I asked the question that how many continents do we have now? Anyone going for 3 marks?
4.
4. Hafiza, name them. Yeah, can you name the 4 continents as you have said?
Hello, sir.
Yeah, hello, I'm listening.
I think we have uh,
There are more than 4 continents, so
I think we have 6 continents.
okay. So when you say it, you tell me their continents.
Okay. We have Asia.
Okay,
We have North America,
okay.
South America,
Mm-hmm.
Africa.
Are you
Uh,
done? Mm-hmm.
um,
Should I
Europe,
give you one?
Europe.
Europe. Okay.
Yeah, and um,
The last one start with an A.
Australia.
Australia. Very well. So Evans, three
Sir,
marks for you, eh?
thank you, sir.
Uh-huh. Today I'm in the mood to share marks. So you do well, I'll give you marks. Okay.
I hear, sir.
So that is it. So according to Alfred Wegener, so keep take note of it. When it comes to what we call continental drift, it was propounded by the person called Alfred Wegener. He was a German scientist. Now, according to him, the continent was together as a supercontinent called Pangaea. Then, as a result of tectonic movement or plate movement, it broke down into two to create what the Gondwanaland and Laurasia. Now the movement continued, and thus now we have what the 7 continents as we have today. Is that okay? So you take note of that. Now one will ask, what is the evidence that the world moved, or the continents were earlier together as one. Now, when we look at first off what we call the rock formation, okay, so according to Wagner, he believed that Pangaea broke apart. Large geomorphic structures such as mountain ranges fractured as the continents separated. So if you look at that jigsaw, uh, hello.
Hello.
Yeah, hello. So I'm joining in on a different device. Just follow the video on the screen. Hello, can you hear me?
Yes, sir. I can hear you, sir.
Uh-huh. So I'm joining. My device is running a bit slow. So I've just switched to my phone so that I can continue with the class. I don't want it to delay us. So I was saying that according um to Wagner, Alfred Wagner, when we look at the type of rock or the rock formation at each place, one is able to see that certain rock types that are common, certain rock types that are seem to be common among places. For example, you look at um, West Africa and South America. If you look at the type of rocks or the kind of climatic condition over there, it's similar to that of what? That of Africa or some part of Africa. Similarly, when we look at the fossil remains, there are certain animals that their fossil or quote unquote their remains, their dead bodies, their bones and the likes were discovered in two places. No difference. Is that okay? Again, please, are you hearing me?
Yes, sir.
Good. Then again, we have what? We have the climatic evidence. Now, by climatic evidence, these areas tend to have similar climate experiences. Um, if it's warm or if it's 2 seasons, it's 2 seasons. If it's 4 seasons, it's 4 seasons. There are some places that they tend to experience. Let's say Brazil. Please, how many of you have heard that it has ever snowed in Brazil before? Have you ever heard that it is snowing in Brazil before?
Yes, sir.
You've heard that it's snowing in Brazil, like snow. So Brazil, among some what do you call it, Latino or Latin American countries or the South American countries, they tend to have similar or the same weather pattern, just like we have in Ghana. Okay, so when you look at the evidence, we have what? The evidence from rock formation, where we find similar rock types in two different places. All right. Then we have evidence from fossil, that is the remains. Animal remains are similar. Plant and animal remains tend to be similar among some areas. Then also we have what? Climatic evidence. Then when you look at the first one, that is evidence from rock formations, you can liken it to what we call the jigsaw approach. Now, let's look at this diagram here. Looking at this diagram, you see that if you should move this part, it will fit perfectly into this area. Then America will also come in and close. Please, I hope you are following. If you look at Antarctica, Antarctica will fit perfectly into South Africa. Uh, Madagascar will also join South Africa here. This will also come in. Europe and Asia will all come together. So there's that jigsaw mechanism or jigsaw approach with these places. Is okay, which also tends to be an evidence of what continental drift. So you can have a question, and the question will ask you, what are some of the, or maybe explain. Hello.
Hello?
Yeah, was there someone asking a question?
No.
Okay. So there can be a question that um explain state and explain any two evidences of continental drift. Let's see. Oh, someone keeps calling the WhatsApp platform. Oh, okay. Yeah. So the question is mention any two evidences of continental drift. Mention any two. So mention and explain any two evidences of continental drift. Yes, for 2 marks. Let's see who will have it. Um, Evans, you are not part. So just so you know, you have your 2 marks already. So let's try Jacob. Hello, Jacob. Would you want to give it a try? Okay, anyone? Rebecca. Hey, I always forget Rebecca is not a lady. Please, the one using Rebecca, what's your name?
Frank,
Frank. Okay, Frank, do you want to try?
a question again, please.
So, explain any two evidences of continental drift as explained by Alfred Wegener.
One is evidence from fossils. That's the remains of plants and animals. And the other one is climatic evidence,
Can
which
you
deals with.
explain? You have just mentioned them. Can you explain them for better
And
understanding?
the first one, which I mentioned, which is the remains of fossils.
Okay.
That's plants and animals who lived once on Earth. And the
Okay.
second one is climatic evidence, which also deals with the changes in the climate and the weather, which also causes. Uh, Please, can you help me? Hello.
If I help you, you get only 1 mark. You won't get the full 2 marks.
Okay.
So do you still need the help?
Yes, sir.
Okay. So when we talk about the climatic evidence or evidence from climatic condition, what it simply means is that the there are areas or there are places on the earth surface that has what um similar climatic experiences. For example, as I mentioned, when you look at South South America and part of Africa. So if you look at the jigsaw that I placed or I showed, if you look at the jigsaw that I showed, you notice
Yeah.
that, sorry, if you look at the jigsaw that I showed between West Africa or Africa and South America, you see that places around South Africa, as South America and West Africa would have what similar or the same um what do you call it? Same climatic condition. I
Okay.
hope it's okay.
Yeah.
Great. So you have only one mark. Oh. You don't have two. Don't forget.
Okay. Yeah.
Okay. So today after the class or during the presentation, you just remind me. So Frank and Evans. So Frank 2 marks, Evans 1 mark. Let's continue. Now, what are some of the critiques to the continental drift? Now, there were two major flaws to continental drift. Now, the first one is it did not satisfy or not clearly explain what force. Just a moment, my screen just went off. Okay, so it did not clearly what explain the. So it didn't clearly explain the force that was responsible for the pushing. And again, it didn't tell how strong the force was. It just says there was a force. Oh. It just says there was a force, and that force is what caused the movement to happen. The second one is they questioned how the continents were moving, but Wagner had proposed that the continents were plowing through what? A stationary ocean floor. That is to say that now the was the Earth mass or was the Earth static? Was it standing at one place? Was it tied to a particular part in the sea? So, for example, let's say you are preparing soup, all right, and in preparing your soup, oh, why does it keep going off? Okay, now in preparing your soup, you see that you can see something floating on top of the soup, but then let's say the meat. But if you want to pick what is floating, you'll notice that it is attached to something bigger. Now the question scientists kept asking Wegener was, is it that the continent was like was it like a boat on the water, or it was actual landmass that was stuck on it? That was the question. Because if you keep saying that they are moving and they are moving and they are moving, then how were they moving? But then it is known that the core and the mantle were not solid, but then the crust was what? Was solid. So we should take note of that. So one, we should know about the evidences of what? Of continental drift. Then additionally, we should know of what? The critiques or the criticisms of what? Of continental drift. One being what? That there was no explanation as to what the strength of the force that was pushing the large land masses across such great distances. Then the second one had having to be the land masses floating. Now, if they are floating, how are they floating? Is it that they are very light, so that they are not tied to anything on the ground? Because those were some of the questions that Wagner was asked to answer to. Now, the next one is what we call the sea floor spreading. The sea floor spreading. Um, okay. Now, let me summarize what sea floor spreading is. Now, when we talk about sea floor spreading, what we try to say is for everything that is happening on the surface of the land or the surface of the earth, the same thing happens underneath what? The ocean or on the ocean floor. Everything that is happening on the surface, the same thing happens underneath what? The ocean floor. So sea floor spreading generally looks at that the processes, okay? It looks at the processes that are responsible for the changes in what? In the ocean bed. For the changes in what? In the ocean bed. So we have the likes of what? The ocean floor topography. Now with the ocean floor topography, data that were collected using the sonar and the mag- magnetometer discovered or helped scientists discover vast underwater mountains chains that they called what? The ocean ridges. So you come on the surface of the earth, you see that there are chain of mountains. If you are going to go range, for example, there are chain of mountains underneath the surface of the earth also, or under the ocean. There is also what? The what do you call it? The ridges or such mountains also created there. What is happening? So topography basically looking at the landform, but then ocean floor will look at those landforms under the ocean or on the ocean floor. Then we have the next one being the ocean rocks and sediment. We have the next one being what? The ocean floor, ocean rocks and sediment. Also from the same analogy. Now once these materials, okay, once these ridges tend to break down, there are evidences of what? Of rock fragments. Is okay. The evidence of rock fragments everywhere. There are sediments also that oh goodness. There are sediments of rocks also that help to understand the kind of soil or the kind of terrain that they are working in. Are we good?
Yes, sir.
Okay. Please just give me a minute. My device is running a bit slow, so I want to get my book. Okay, I think I managed to get it to come. So as I said, whatever happens on the surface of the earth, the same thing happens underneath what underneath the earth, or basically at the base of what of the earth. So here we have thick sediments, we have thin sediments, we have the ocean ridges, which looks like mountains or mountains that have been formed. Then you have what the old rocks as well as what the young rocks. Then we have what we call the magnetism. We have a process called magnetism. By magnetism, we should know that the earth has, or it's more like a magnetic field. Okay, the earth is more like what a magnetic field. Now, with this form of magnetism, it helps it helps the scientists to know where where they can find large amount of iron bearing materials. Now, with volcanic eruptions or volcanoes, these materials have high levels of what of iron. Okay, and iron we know is a metal, and are um these metals tend to be attracted to magnets. So once it's attracted to magnet, it means that what it creates some form of magnetic field around the earth that the earth uses, or that can help in most especially directions or getting the right direction to places. Okay. Now let's look at this. Let's use this image to understand what we mean by sea floor spreading. The sea floor spreading. Now, as mentioned earlier, the earth as we see it undergoes certain changes. And I mentioned that whatever changes you see on the surface is the same changes that occurs also under what under the under the sea. So under the sea there is also what we call the volcanic eruption. But then because the molten materials do not erupt out of the sea, they tend to what, spread slowly or gradually on the they tend to spread slowly on the surface. So if you look at this first image here, once there's an eruption, there is opening or there's an opening. Now the opening will force or create the magma to come out. Now as it comes out, because it's meeting with what with moisture, it does not erupt out, but then it tries to spread. Okay, so it tries to spread out and fill out what empty spaces, or fill out what we call what the trenches. Now trenches are what they are the deep part of, or the let's say the deepest part of what of the ocean. I think the deepest trench we have is what we call the marina trench. The deepest trench we have is called the marina trench. Yes. So, Please just a moment. I just have to disconnect my laptop completely because it's not coming. Okay. Okay. Come. I'm okay. Okay. All right. Good. So please just listen to me. The projection is not going as planned. So looking at seafloor spreading, as I mentioned, we try to look at all the processes that are happening under the surface. Now it says it's a theory that explains how new ocean crust is formed at ocean ridges and how new so it says it's a theory that explains how new ocean crust is formed at ocean ridges and destroyed at deep sea trenches. So as these changes are occurring, others are building up, whilst others are also are also getting destroyed. Now know that or remember that according to Wagner, the plates keep moving, and as they are moving, it means that new things will be happening. Whilst new things happen, old ones will just be destroyed or will be taken out. Are we okay? Now we have what we call plate tectonics. Now plate tectonics is a build up of or is an aspect from Wagner's theory that the earth continues to move or it keeps moving, and it's for that reason that we have those changes happening. Now, according to Wagner, or according to the theory of seafloor tectonics, it's a theory that describes how tectonic plates move and shape the earth. How tectonic plates move and shape what the earth. Now, if you look at the image on your screen, you see that each area has a plate. Each continent has a plate, and with the continent, the once the plates move, it means that there's something that what will be happening at the edge or the edges. Now, in terms of the movement, we have the divergence, we have the convergence, and we have what the transformational. When we pick the divergence plate tectonics, it means that these plates or two continental plates tend to move away from each other. Again, the divergence means that they deviate, so they move away from each other. The convergence means what? They move against each other. So whilst divergence, there one is going left, one is going right. Convergence, they are all what? Meeting at the same place. Then transformational means they are passing by themselves. So they are not meeting, they are not going in opposite direction, but then they are just moving just by themselves. So just across. Is that okay? It's just like two cars. One can just pass by the other. That is the transformational. Then convergence will be collision. So convergence will be collision. So A will go and meet head on with B. Then we have the last one be what the divergence, which means that they will move away from each other. Very good. Then let's look at volcanism. This one I have some slides on it. I would do want to share with you. So volcanism, plate tectonics, continental drift. I'll do want to share with you. So when we look at volcanism, we try to look at all the processes that are responsible for magma to escape from within the earth onto the earth's surface. Is that okay? Now, when magma escapes from the earth's surface, escapes from within the earth onto the earth's surface, it now changes to be called lava. So when it's within the earth, it is called magma. But immediately it comes onto the surface of the earth, it is now called what? Lava. The anatomy, okay. There are types of eruptions, okay? Now looking at the eruptions, we have the quiet eruption, we have the explosive, then we have types of volcanoes. So generally, when we want to look at the types of volcanic eruptions, we have two. It's either when it's erupting, it will be quiet, or it will be what? It will be explosive. The quiet means that when it's coming out, it doesn't make noise. It is just slow, soft, then it just comes. Then we have what? The explosive. Where the explosive means it comes out with what? With loud force or loud noise. Then when we look at the types of volcano, we have generally about three of them. We have the shield volcano, we have the cinder, they have the composite. Now the shield volcano is said that um when there an eruption occurs, it the lava or the magma within the earth, once it gets to the surface, it comes out slowly or through a gentle or a quiet eruption. It's gentle or it's quiet, then it comes out slowly through the crater, then it lands on the side. Now it will do that continuously over a period of time. So it comes out, it cools down on the side, then it solidifies. Then another time, the same process again. It cools down and it solidifies. Then it comes again, it cools downwards and it solidifies. Then at the end, it forms some form of or it creates some form of what? Shield. All right. Now we have the cinder, where the cinder is a type of volcano that has very steep sides. Okay. Now it's important to know that they come up from what? Small explosive eruptions, and they are made of the polycastic what materials. Now they are quite small in comparison to what? To the shield volcano and the composite volcano. So when you look at the cinder volcano, they are relatively what? Smaller. Whereas the composite volcano also looks at what? Alternating layers of hardened lava. So they come out, then it solidifies. They come out and it solidifies. They come out and it's what? It solidifies. Now it's important to know that all these three types of eruptions or these three types of um, volcanoes have different role it plays based on how it is. It is either explosive or what or non-explosive. Some are very gentle. For example, the composite volcano, depending on the content of magma or the reaction of the magma to the earth surface, it tells whether it will be gentle or it will be whether it will be quiet or it will be explosive. Is that okay? Any questions to this point? Hello, any question? Hello, are you there? Any question, please?
No, sir.
Okay. Then let me ask this. Yeah, hello, Jacob. You have a question? Okay. Now, what is. Okay, sure. What is an earthquake? Now, when you hear earthquake, what comes to mind?
I was late to that, so I just came.
Oh no, this one is general knowledge. It's general knowledge. When you hear earthquake, what comes to mind? Not just you, it's to the whole class. Teresa, you have not said anything. So it's the movement of the earth crust.
Yes, please.
Okay. So it's important to know that when you look at the ouch. When you look at earthquake, yes, it's the movement of the earth crust, but then it is the sudden movement of the earth crust as a result of what? Of sudden release of energy. Is that okay? So when you look at earthquakes, it is defined as what? As the sudden or the as is defined as the sudden release of what? Of energy from the earth, which causes it to what? To move, or is the movement of the earth as a result of the release of what? Sudden energy. Is that okay? Other books too will talk about the strain and the likes. Now, earthquakes mostly happen along what we call the faults or the fault lines. Now, a fault is what? Is a break in a body of rock along which one block slides relative to what? To another. Now, because the earth continuously moves as a result of the plate tectonics or the continental drift, as they move, they'll stop, they'll continue moving, then they become what? Stressed. So once there is stress, there's also the sudden what? Release of what? Of that energy. So there's a sudden release of what? Of that energy. Now once that energy leaves, then we have this thing coming into play. The earthquake coming into play. So you look at this, no strain. Now compressional force means that there are forces that will be pushing or working side by side or be pushing the earth side by side. The intentional force will mean what? They are trying to pull them apart. Then shear force will mean whilst one force is pulling it away, another force is also pulling it what? Closer to itself. So at the end of the day, you have something like this. Now, once all these things are happening, there's what we call what? The stress and the strain, which will result in what? In earthquakes. Then we have types of fault. We have the reserve fault, reverse fault, sorry. We have the normal, then we have the strike slip fault. The images makes it clearer. So when you pick the reverse fault, whilst one force moves down, another force pushes it up. Then when we look at the normal fault, it's just trying to what? Move away from each other. Then we have the strike slip for fault, where they move against each other. So they move just by the side of each other. Now, when we look at an earthquake, we have some few things that we need to know about it. Now, the location within Earth along a fault, or the location within Earth along a fault at which the first motion of an earthquake occurs is known as what? The focus. Again, the location within Earth along a fault at which the first motion of an earthquake occurs is called the focus. Now, the point on Earth's surface directly above um directly above the focus is called what? The epicenter. So if you look at the diagram here, this point, the middle section over here has what? The focus. Now, the focus is always within the Earth. The focus is always within the what? The Earth. Then the place directly above on the surface of the Earth where the earthquake happens or the earthquake can be felt is what we call what? The epicenter. So please take note of the two. Focus is within the Earth. That is the first place the motion of an earthquake occurs. But then the point on the surface of the Earth where it is felt, or the first place it is felt, is what we call what? The epicenter. Is that we good? Is that okay?
Yes.
Now, the
Yes, sir.
next one we look at is what? Is the seismic wave or the earthquake waves. Now, we have generally three types of what? The seismic waves. You have the primary, you have the secondary, and you have what? You have the surface. Now, with the primary wave, also referred to as what? The P wave. Now, they squeeze and push rocks in the direction along what which the waves are traveling. Now, what this means is that coming to the coming to the image, are we seeing that there are three circles, right? You see that there are three circles. Now, the first one is the primary, the second one is the secondary, then the third one is what? Is the surface. So, looking closely, you realize that the primary and the secondary hardly get to the surface, but then the surface waves just happens what? On the surface, or it's mostly what? On the surface of the Earth. What this means is in here there is that pressure on the rocks. Is that okay? Whereas the S wave or the secondary wave are relatively slower. So like you doing something, or maybe someone is playing music in the house or in the room. You hear that there's someone playing music, but then it's not so loud. You only get as you get closer and closer and closer, you realize that, oh no, the music is relatively very, very loud. Then immediately you enter, you realize that the music is very loud. So the same thing happens with the seismic waves or the earthquake waves. The primary one is the one that is just around what? Around the focus. The secondary the secondary wave or the S wave is the one that you can what? You can feel at the epicenter. So relatively it is slower. But then the last one, which is the surface wave, that one is the slowest of all. And with that one, what it means is it travels only along what? The Earth's surface, meaning as places within the Earth are shaking, that side it doesn't shake. It just has, or it just gets, a feedback of what is happening. Okay, are we fine?
Yes, please.
Okay. Now we use a seismograph to measure so vibrations in the earth can be detected and recorded by using an instrument called the seismograph. Now the recording that is done by the seismograph is called the seismogram. So the seismograph that's the is the instrument or is the name of the instrument. Now the instrument records the vibrations that happen, and that vibration is called what? The seismogram. That tracing of it is called a seismogram. Now the vibrations of the earth is measured using what? Magnitude. So the higher the magnitude, the stronger the earthquake. So magnitude 1.0, it means they are not very strong. But then when you get a magnitude 7.1, I think those of you who are football fans, the one that killed Cristiano, for example, was I think a magnitude 6.7 or 7.2, one of it earthquake. Okay. Then on to the last one, that is mountain building. Okay. On to the last one, which is mountain building. Now, a mountain is a landform that rises above the surrounding terrain in a limited area. So you go to a place for a mountain, for you to term a place as quote and unquote a mountain means the place needs to go to be higher than the other. So you can just use your colleagues for as examples. If you tend to be taller than your friends, it means you're a mountain. Is that okay? If you tend to be taller than your friends, it means what? You're a mountain. Is that okay? So once it needs to what? An area higher or above these surrounding areas. Now they are usually made up of what? Of rock and earth. Generally, mountains are higher than 600 meters above the sea level, obviously. And those less than 600 meters are called hills. Now, for mountains, they cover 1 feet. That is, should we divide the earth into five? It covers one of it, and occurs in 75% of the world's country. So it means literally every country that you go, you find what? A mountain. For every country that you go, you find a mountain over there. Now, what are the types of mountains we have? We have the fold mountains, we have the block mountains, we have the dome mountains, volcanic mountains, then the plateau. Now, fold mountains uh, are those with the anticlines, cyclines, anticlines, and the monoclines. So it's more like you press, um, let's say you buy bread, okay. Now, holding the bread, if you press the side and side of it, the extreme ends of the bread, you press it, you realize that there's this kind of wavy or there's this kind of wave on the bread. Now you can liken that to be what? A fold mountain or the fold. Then the block mountain on the other hand. Now these mountains formed by a fold. These mountains form when faults and cracks in the earth crust force some materials or blocks of the earth to move up, meaning that people are falling, or there could be an area that will fall. Is that okay? Let me show you the image over here. So please look here. Now you see that where they are blocked, it means the surrounding areas stayed back, or they fell, or they didn't move. Now the first for a block mountain to happen, there should be what, a line of fault or crack. There should be a line of what, of crack. Now once that happens, then we can have what, the extruded part being what, a block mountain. Then the last one, the third one being the dome. Now the dome, this is how the dome looks like. The dome looks like how do I put it? Like a bow, an upside down bow. All right. So there is something within the earth that is pushing, or there's a strain that is pushing the surface out. So it creates or it gives it that kind of what, the bow feature. Are we okay? Then we have the volcanic mountains also coming into play. Then we have what we call the plateaus also coming into play. Now this question, 6.3, 6.3, why they need to study mountains? 2 years ago or last year, it came during their end of, no, 2 years ago. Yes, 2 years ago, it came during their end of semester exams. They were asked to um, write, I think, any four importance of mountains, or four important why we need to study mountains. It looks like general knowledge, but then it's important to know what these mountains are. So mountains are important for water, because water, um, it's aids in what we call the filtration process. Then it houses large stores of water, or it stores more large amounts of water. The second one is that um, they matter for disaster risk management, such as issues about climate. Because if there is a strong wind and you stay in a valley, it means that when the wind is coming, it will hit against what, against the mountain. Then the wind moves up. It doesn't come down to you. Now it's important for tourism. Those of you who have gone to Afajato or Afajato, you can attest to that. It's also important for food. Because of how the nature of the soil over there, you can be able to use what, to cultivate. Some animals also enjoy staying there because they feel protected. Now, once hunters go over there, they're able to what, to get hold of them. Now, they matter for the youth, they matter for indigenous people, as well as what, the biodiversity of places. So, in summary, when we look at issues about the dynamic nature of the earth, we have issues such as what, the continental drift, which according to Alfred Wegener, the continent was together as one supercontinent called the Pangaea. Now, after breaking down, it came to form what, Gondwanaland and Laurasia. Then it further broke down to form what, the continent as we have today. Then we have the sea floor spread, where we look at everything that is happening on the surface of the earth. The same thing happens underneath the earth. We have plate tectonics, where we come to understand that for the movement of plates, they try to move away from each other, or move against each other, or bypass each other. We have volcanism. Volcanism, we look at all the processes and the methods responsible for what, the eruption of magma onto, or in between what, the earth surface. Then we have earthquake, where we look at the sudden release of stream, or sudden release of energy um, from the earth. Now for the first place where the earthquake is felt is called what? The focus. Then the place immediately above the focus on the surface is what we call what? The epicenter. Is that okay? Then last one we have mountain buildings where we've come to understand that for we see a place to be a mountain when it's above 600 meters. But then if it's below 600 meters, then it means what? It's a hill. Is that okay? So are there any questions for me?
No, sir.
No, sir. No questions. So are we okay?
Yes, sir.
Okay. So I'm told your groupings will be ready. I'm told your groupings will be ready hopefully by close of the or early tomorrow. Once I hope you have all filled the form though.
Yes, sir.
Okay. So once it's done, I would share your presentation areas with you. Then we can take it off from there. Is that okay?
Sir, please, I want to ask a question.
Okay, I'm listening.
The presentation, are you doing it here or we go to our various campuses?
No, you do it online. Everything is online.
Okay.
Yeah. All right.
Okay.
So if there are no further questions, Jacob, do you have something to say?
Yes, sir.
Okay. So if there are no further questions, I want to say thank you very much for your time, and I wish you the very best for the week. And do have a wonderful day. Bye.
Thank you very much. Same to you.
Bye bye.
Okay, sir.
Yes, sir.
Bye.